Today we're discussing simplifying radical expressions. We are going to be focused in on just the square root format. And so let's talk about what square roots are. We've done a little bit of them last semester when we were talking about factoring. So like if I had 5 squared, that's going to give me 25. Well, the square root of 25 is equal to 5. If I have 7 squared, that's going to equal 49. The square root of 49 is 7. You notice that the square root, once I take it, it goes away and it just leaves us the number. Just like if after you square something, you don't write squared again. Not all the problems we are going to work with today are going to need a square root and it gives us a nice solid number. Sometimes there are multiple things inside it. So let's look at problem 1. Problem 1 says I have 216 x to the 7th, all of that being square rooted. So let's first simplify the 216. To find out what we can bring out of the square root, we need to find all the perfect squares. Sometimes you'll know right away, hey, this is 5 squared, or it is 25 squared, or whatever it might be. Other times, you're going to have to go through and I use upside down division to help me find them. So 216. I'm going to factor that out using the primes. And for focus points, I recommend, and for all my assignments, these will get you started enough to where you can find the factors afterwards, is using the prime factors of 2, 3, 5, 7, 11, 13, and 17. Most of the ones that we'll be using will be these guys that can help you discover. But just realize that 13 and 17 are also there. Those won't be used as much to get you started. They may end up being a part of it, but they will not. You won't need them to get started. So let's go ahead and do the prime factorization of 216. I want you to pause this or to do it on your own. Come back and see what it looks like with it. And so 216, we have divided by 2 is the way I would start, giving you 108. Divide that by 2, giving you 54. Divide that by 2, giving you 27. Now, that's no longer even. So I know I can't divide by 2, but 3 will divide into 27. So 3 gives me 9, which gives me 3 and gives me 3. Now, looking back, are all of these numbers prime? If the answer is yes, you did good. If you have any of them that are not, just factor them out a little bit further. And so like if I had instead said this was a 9 here, I would need to take and go, okay, what 2 things are going to go into 9? Because our goal is to get down to the prime factorization. So for this, I have 3 2's being multiplied, 3 3's being multiplied, and I have 7 x's being multiplied. You will not have to write these out each time like this, but this helps us at the beginning as we're starting to see how things work. So I am going to look in here and see, okay, I have a set of 2 2's. So I'm going to write that 2 down. I have a set of 2 3's. So I'm going to write that 3 down. I have 1, 2, 3 x's. And this time I'm going to write it out separately. You don't have to write it that way. You can go ahead and go down to the next step and say that's x cubed. But if you need to see it, that's how it's looking. Now let's see what is left behind. What did not have a partner to come out of the square root with? And these guys did not have anything with them to help them complete to get out of the square root. So left behind in the square root, we have 2 times 3 times x. Now we want to simplify this to get it to where it is all gathered together. And that means we have 2 times 3, which is 6. X cubed times the square root of 6x. And that is your answer. We're going to do a couple of these. So, again, starting off, I need to figure out, okay, what do I have? So I'm going to take that 392 and find out what it can simplify with. Well, it's even, so I'm going to start with 2. So 2 will divide into 3 one time. 19, it'll go in 9 times. And 12 will go in 6 times. Now we're going to divide into 196. Hey, we just did this one, so we know some of these numbers are. We know it, and so we have 83. Excuse me, I realized we did something else. We did 216, excuse me. And we have 83. Excuse me. 93. So when we divide that by 3, we end up with 31. Now, I start going through that list. Is it divisible by 1, 2, 3, 4, 5, 7, 11. And then you go, okay, no, it's not divisible by any of those. Well, is it? And we're already halfway through it. 7, excuse me. Then we go on up to the next prime number is 13, 17. And it turns out this is a prime number. And if you want to go ahead down to 1, you can there. Or I could have just taken and erased that box and said, okay, there we go. Write down my primes. 2 times 2 times 3 times 31. Now, for variables, I had x and y to the 4th. So we're looking for sets of 2 that we can bring out. So there's a set of 2 2's, there's a set of 2 y's, and there's another set of 2 y's. So what was brought out of the square root is 2y squared, because we had 2 of those y sets. What was left behind was everything else. So the 3, the 31, and the x were left behind under the square root. They didn't have anybody to join up with to get out. And then simplify any math that you may not have done. And we end up with 2y squared times 93x. And that whole thing is your answer. Now my square roots, you notice how I keep that line going until I finish up with what's under the square root. That needs to encompass or cover everything that's in the square root. Now this next one, we have negative 6 times the square root of 200 x squared y to the 4th. And so that negative 6 is not under the square root, so I don't do anything with it at the beginning. I'm going to take the 200 and divide it by 2. And that gives me 100. And somebody might know that 100 is 10 squared, and that's fine. If you want to go to that step where you know both those numbers, that's fine. Or if you did not know that, let's go ahead and keep going with the primes. Divided by 2 gives me 50. Divided by 2 gives me 25. Divide that by 5 gives me 5, and 5 is prime. So I'm going to write down my factors. 2 times 2 times 2 times 5 times 5. And then I had x times x, and y times y times y times y. So I'm looking for those sets that can come out. I have a set of 2 2's, a set of 2 5's, a set of 2 x's, a set of 2 y's, and another set of 2 y's. Now that negative 6 just hangs out in front. It's going to multiply times everything that we bring down. And so I have a 2 that was able to be brought out, a 5 that's able to be brought out, an x that's able to be brought out, and then 2 y's that were able to be brought out. And that leaves behind a square root of, well, the only thing we have left is a 2, so square root of 2. Now we're going to multiply everything together that can multiply, so those 3 numbers, negative 6 times 2 times 5, so that's 10 times negative 6, so negative 60 xy squared times the square root of 2. That is the answer.